Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong, AWS, and Datadog. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting webinar for you today. First, I do just have a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, or you would like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we encourage you to send those in at any time throughout the program by using that Q&A tab that you will find on the right side of your screen. You'll also notice the chat tab, and that is where we want you to get to know your fellow audience members. Let us know your thoughts, or maybe just from where you're joining us. I'll also point your attention to the Handouts tab. We've got a couple of links available there to aid with today's webinar, so feel free to check those out. And of course, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is Monitor EKS Blueprints with Datadog and AWS. And I'm joined by John Kendall, Senior Product Manager at Datadog, and Lucas Duarte, Senior Specialist Solutions Architect for Containers at AWS. John, Lucas, thank you both so much for joining me today. Lucas, you want to take it away from here?
Yes, it's my pleasure. So let's start my screen share here. And we can start. I think we have it. John, are you able to see my screen?
Yeah, we're live. We're good.
Great. So yeah, guys, thank you for your time today. My name is Lucas Duarte, as Cody presented me. I'm a Senior Solutions Architect here for AWS, focusing on containers. Right now, I'm based in Latam. So I live in Brazil, São Paulo. And John, if you want to present yourself before we start.
Yeah, for sure. Hey, everybody. My name is John Kendall, and I'm a product manager here at Datadog, focused on everything related to containers. So excited to talk about how Datadog makes your life easier with AWS environments like we're going to talk about, as well as we work everywhere. So my job is to hopefully make your life easier with containers, and look forward to engaging with you all.
Yes, we're all excited for this webinar. And so let's just head into the content. So here's the agenda. First, we're going to talk about a little bit EKS architecture. So please, as Cody said, if you have any questions, please put those on the Q&A tab that we have here. Then we are going to forward to observability. So we're going to see how observability works in the context of microservices and how it differentiates us from a monolithic application to microservices. And obviously, observability with the Datadog and how it can reduce our operational overhead inside our observability stack that we are going to install in an EKS cluster. Then we're going to talk a pretty new framework that is called EKS Blueprints. And EKS Blueprints is a framework, and John will dive really deep on those on this content. And last but not the least, the EKS Blueprints with Datadog and how we can easily implement the Datadog agent with this pretty new framework. So let's start with some principles of the Amazon EKS. So for AWS, security is our top priority. So we have implemented mechanisms in EKS to increase the security level, such as IAM roles for service accounts and the IAM authenticator. And those are add-ons that AWS installs for you when you spin up a cluster that enables you to use your IAM users and groups in order to authenticate and authorize what the users and groups can do inside a cluster. Usually when you have a self-managed distribution of Kubernetes, you don't have a way to authenticate the users. So AWS integrates the IAM for you to simplify your life. EKS is made to support scale production workloads. Probably the most part of the audience that is here today already know that the EKS can support like production workloads, but there are customers today that want to scale in very large clusters with more than 1,000 nodes. And we are able to support that also. Third, AWS does not add anything special, and that is really important. So does not add anything special into Kubernetes. It's pure native and upstream Kubernetes distribution. So that means if you have a self-managed cluster run inside your account in your on-prem environment or maybe another cloud provider, you can easily deploy your applications inside EKS without any changes on the manifests. So that is really important. And we also make sure to other AWS services stay well integrated on EKS so that customers can leverage breadth and depth of our services. And the last one, we are compromised to open source contributions. So AWS have a lot of projects that AWS contributes to, such as EKS CTL and VPC CNI, IAM Authenticator. All of those are open source, so we are compromised to cover that also. So let's look at the high-level overview of the EKS architecture. This is just a high-level overview. Obviously, we have many components installed in the EKS control plane and also in the data plane, but we're not going to cover those here in this presentation since the focus is observability. So the control plane is architected across 3 availability zones at least. And the components in the control plane run in a single tenant AWS VPC, 100% managed by AWS. What that means is that the VPC that the control plane sits in is all abstract for the customer. It's a single tenant VPC that AWS takes care of, and how the managed node groups and the self-managed groups and Fargate are able to communicate with the API server. The AWS places an ENI inside the customer VPC, as you can see here in purple on the left side of the screen. So it places the ENI here, and with that, the worker nodes are able to join our cluster. And AWS also recommends we recommend you to run your clusters inside a VPC that have public and private subnets in order to create, for example, load balancers or ingress controllers in a public and private way, depending on your application, depending on how you want to expose those services inside your environment. Since the focus of that webinar is to talk about observability, one of the most important things to analyze when dealing with EKS is the control plane logs. With EKS control plane logs, it can provide audit and diagnostic logs sent directly to CloudWatch. It means that if you want to check who did what inside your cluster, you are able to do that using the audit logs of the control plane, and those are forwarded straight to CloudWatch logs. And you can enable those logs when spin up the cluster or afterwards. You can choose it. And there are 5 different types available, and each log type corresponds to a component of the Kubernetes control plane, such as API server, scheduler, authenticator, and as I said before, the audit logs. So they are all indexed into CloudWatch, and we are able to check those when we want. The last point that I want to talk about EKS before we're going through observability and a little bit more deeper in this aspect, EKS now supports 3 flavors of runtimes, 2 that runs on top of EC2 and 1 in Fargate. In the EC2 context, there are 2 kinds of node groups. So let's start with the managed node groups. With managed node groups, we can provisioning the node group during the cluster provisioning, and is fully integrated with EKS, and you can deploy it when deploying your cluster. And what the managed groups are used for? One of the main concerns when dealing with Kubernetes and application that sits inside EKS is the upgrade process of the control plane. Since Kubernetes launches new versions each at least 3 months, we have to stay tuned to upgrade our control plane. And with the managed node groups, you are able to have the AWS support to upgrade your control plane. It means that it can, once you upgrade your control plane inside also, in AWS will handle all that for you. You can click on a button or even using a CLI or using the EKS control CLI to upgrade also your managed node groups. And what AWS is going to do is going to take those node groups and start to rolling update process inside those node groups. And the second option of EC2 that we have right now is the self-managed node groups. So different from the managed node groups, with self-managed node groups, you need to provision it after the cluster is provisioned. Again, via console, via CLI, via EKS control. And with self-management groups, as the name said, you need to manage all the components of it, including the upgrading process of your worker nodes. So the management groups supports rolling updates, and AWS can handle it for you, but self-managed groups does not support when we can use one instead of another. So right now we don't have why to use self-managed node groups anymore. Just if you have Windows worker nodes or some kind of Aws architecture that management groups does not support. But usually for Linux, you are fine. You can use management groups and take the advantage of what it can offer. The last one, but not less important, it's Fargate. And Fargate is fully integrated with Amazon EKS and enables you to run your containers in a serverless way. So it means that you don't need to handle all the infrastructure components for your EKS cluster, and AWS will handle everything for you. And yes, we are able to use both EC2 and Fargate. We just need to create a Fargate profile inside EKS, and we are fine. In the Fargate profile, we specify the namespaces that we want to, the applications that's going to be deployed go to Fargate, and which namespaces you can steal on EC2. So it's really easy, and we can easily implement those on EKS. So
with that, we actually just got our poll results in on whether you're using EKS on EC2 versus Fargate. And around, 69% are using EKS on EC2, 19% EKS on Fargate, and then the remaining 14% are not using EKS at the moment. And yeah, this is interesting. As a product manager and watching Datadog users as well as AWS users figuring out what's best for managing their underlying hosts, there is a trend of organizations migrating to Fargate, specifically on ECS. We talked about this in last year's 2021 container report that we release every year. And at that time last year, it was approaching 40% of ECS customers using Fargate. So this appears to be aligned with that trend. And so I don't know if you have any comments there, Lucas.
Yeah, what I think is like Fargate, it's really useful because you don't need to handle all the infrastructure. But now for Fargate in EKS, to be honest, I think we are improving the service, like the connection between EKS and Fargate. Mm-hmm. In Fargate with ECS, like since ECS is a AWS solution, is not like community solution, we can well integrate Fargate much better in ECS than we do in EKS right now. But again, we're always developing our services and listen to the customers. So your feedback is really important for us. So please, if you have any sort of advice or something that you want to the AWS implements, talk to your account team, and your accountancy can help you with that. But I think, John, for ECS, Fargate is stronger than EKS right now, is what I have seen the customers that I talked to also. Mm-hmm. Mm-hmm. Awesome. Do we have any questions until now?
So I am seeing one question that reads, are you doing both Linux and Windows containers?
In the context of this presentation, we are going to do a live demo, and I'm not going to spoil it before John takes it. But what I was saying is that we can use Windows containers, but management groups does not support Windows containers, just the self-management groups that supports Windows containers. But yeah, you can use both inside EKS.
Yeah, and same with Datadog. We support every kind.
Great, Cody. Thank you. So heading straight to observability, that is the focus of this webinar. We are living in a time that microservices are everywhere. With this kind of architecture, we have like many benefits: scaling, velocity, reduce the time to launch new features, and many more. But unlike a monolithic application that you have just one place to look at, a microservices approach is composed of many components, and each individual component needs to be monitored. So there are many benefits when dealing with microservices, but there are also some things that we have to have in mind, like observability. So observability in the microservice context is much more complex than in a monolithic application, because what I've said. So with that in mind, observability comes in. So observability, the context of observability, the concept of observability is the ability to collect information at all three layers of the stack, as I'm showing on the screen. And yeah, when talking about observability, we have three main pillars that we focus. So the metrics is the ability to collect and visualize data regarding the health and performance of resources measured over intervals of time. So those are metrics, and we're going to cover that in the next slides. What options do we have to cover metrics inside EKS from the community? Logs is the ability to collect and aggregate log files from resources and filter that to get insights. So maybe your application is not performing well, you are seeing a latency increasing, and you are able to check those logs. So we have to have a way to centralize all the logs in a log centralizer. And the last one is traces. So Tracy, John, we're going to cover much more details the traces section in the live demo. But for those who don't know what it is traces is the ability to follow the path of a request as it passes through the different services. So with tracing enabled in our application, we are able to follow the requests and check in which specific service or maybe request it's increasing, for example, latency, or maybe doing a timeout. And with traces is really useful for troubleshooting. So those are the three pillars of observability. And there are some examples of those. So for logs, the database won't start after a update, for example. Metrics, we know that our application is 35% slower because we are measuring it. So with that, we are enabled to get the metrics. And traces, what are the dependencies for the services? And I wrote in a book that is called Microservices Ready for Production. By the way, it is a really good book if you folks want to read. But we have to map the upstream and downstream dependencies of the microservices. That is a way to improve the observability stack. So with traces, you are able to do that all automatic. So you have just to instrumentate your application, as you're going to see in the live demo. But with the traces, we're able to map the dependencies of my services and show it in a graph and beautiful way. Okay, so now that we understood what are the three pillars of observability, let's take a look in EKS. So key metrics to monitor in EKS. We're already talking about the EKS control plane logs. So it's a really good practice to enable those logs to have more visibility in what's happening inside your control plane. But we also have other metrics to monitor. So cluster state metrics is regarding the cluster state information emitted by the Kubernetes API. So how many nodes you have inside your cluster? Those nodes are in a healthy way, and what kind of objects do we have inside the cluster? And those are all cluster state metrics. And we can monitor those installing the Kube State Metrics add-on inside the cluster. So this is the first add-on that we have to install to cover the cluster state metrics. For container and node resource metrics, we also need to install another add-on when dealing with EKS. That is the metric server. So metric server is responsible to translate the kubelet metrics in a way that the API server can read it. And with that, we can scale our microservices that run in EKS with the HPA component that we're going to cover on the next sections. And the last one is AWS Service Metrics, EC2, ELB, ASG, EBS, any sort of services that you are using inside your account. You need to monitor all those services, and Datadog can help us with that. So we need, when dealing with EKS, we need to install many add-ons inside our cluster, and we need to guarantee that those are up and running, and we have to maintain that. So it starts to get really hard to maintain everything. Also, if your SRE and DevOps team don't have many people on it, can focus so much on observability. So we have many ways to implement that. And with the Datadog can help us, and we're going to cover that in the next slides. So we have three pillars: metrics, logs, and traces. So for metrics, Out of the box, EKS doesn't have a default setup for collecting and aggregating, alerting, or visualizing metrics. So that's when Prometheus and Grafana comes in. So as I said before, everything that we need to do inside EKS needs an add-on installed to do so. So in order to collect those metrics, we need to have cluster state metrics installed, metric server installed, and the node exporter installer. And once we spin up those, we are able to spin up our Prometheus server inside our cluster, and the Prometheus server can scrap our services to gather metrics. Remember, Prometheus do a scrapping, is not the application that sends metrics to Prometheus. Prometheus will scrap the metrics inside the application, usually in a /metrics endpoint of your application. Alternatively, we recently launched the CloudWatch Container Insights, so we can do that. We can do all that of metrics all for you in a managed way with managed services. We still need to configure agents inside our cluster, the CloudWatch Container Insights agents. But yeah, it's another possibility that we can use. John, what you have seen a part of Datadog, obviously, but the monitoring solutions that already work at that, so like Prometheus and Grafana, you're seeing that as a trend in the open source world, in the containers world?
Could you repeat what you said?
Like how you see the monitor stack of the customers that you already worked at. So they all use, for example, Prometheus and Grafana, or maybe a different kind of solution?
Yeah, you're seeing a full range of solutions. And as you're seeing these customers increasingly use Kubernetes, and as a matter of fact, as reported in the last container report, the number of pods per Datadog customer has been doubling year over year. And with that growth, there's been a need to have true end-to-end visibility into what's happening at every layer of your technology stack, because it's more complex than ever to manage. So I am seeing more customers using Datadog to be able to see everything from having one place to look at all their logs, to using Container Monitor to be able to see what's going on at the container level to optimize things like CPU and memory, to being able to correlate that with what's going on at the app layer and everything else that you need to do if you're an app dev, or if you're a platform engineer, or if you're another business person that needs to be able to watch and make sure that things are continue to be made available, and to make sure you're doing things in the most efficient way possible. So yeah, people are taking advantage of end-to-end observability more than ever.
Yes, more than ever indeed. So for collecting metrics, we have Prometheus and Grafana, and for the log part of our stack, customers usually, like the customers that I support, usually uses the FluentBit stack with the Amazon OpenSearch or some kind of Elasticsearch to centralize the logs. And what the FluentBit does, it deploys as a daemon set inside your cluster. So it guarantees that just one replica of the application will run in each worker node. And the FluentBit will tail for the logs of the containers. And once it tails, it will send over to OpenSearch or to Elasticsearch or to Graylog. And alternatively, we also can implement log aggregation using Amazon CloudWatch. But again, those are two different dashboards that we have to look at. First one is the Grafana. We're going to look at the metrics of our applications. Then we have a second dashboard. So if you are talking about Elasticsearch, the Kibana dashboard, we have to look at Kibana to look at the logs. So two different places to look at. And for tracing, here in AWS, we have the Aws X-Ray. So Aws X-Ray is a managed service to analyze and debug distributed applications. And we can use X-Ray to analyze applications in both development and production workloads. And yeah, you need to instrument the X-Ray library and SDK inside of your application. Right now, X-Ray supports the main languages, so Python, Java, JavaScript. You can check on the X-Ray service page to check if your language that you're using is supported by X-Ray. But yeah, we have X-Ray to support the tracing. But again, it's a totally different dashboard. If you're using Prometheus and Grafana, if you're using FluentBit and Elasticsearch and tracing, those are three different dashboards that you have to look at. And with that, I presented to you always to cover all the pillars that we have seen so far. But as you saw, each pillar needs different add-ons and toolings to be deployed in our cluster. So it means that the operational overhead increases a lot. As I said before, many teams don't have dedicated DevOps and SREs, teams to create and maintain the complete observability stack, even though there are some of them that are managed services, but we need to manage the add-ons that we're going to install inside EKS and manage also a lot of different places to look at when dealing with metrics, logs, and tracing. So that's when Datadogs came to the rescue, right, John?
Yeah, that operational overhead is real. When you're thinking about people like Datadog, oh, let's take a look at this poll question first.
Yeah, sure.
You know, people that are like some of our customers that are managing hundreds of thousands of containers across tens of thousands of hosts, and you have hundreds of developers that are all working together to create experiences for their own customers. You need that end-to-end observability, and you need to be able to work across your teams. And Datadog, ultimately, what it is an observability tool for those that don't know, an observability and a security tool that's intended to be comprehensive to serve all your needs. So think about, I look back when I was a developer and I had to troubleshoot and watch things to make sure things were available. Being able to at the time I had to manage a pretty fragmented setup of being able to look at my logs, being able to conduct tracing to troubleshoot, or being able to do things like synthetics monitoring. Datadog gives you all of that as in one screen, one app to be able to conduct all your observability needs. And it looks like here, over half, 61% of our people here are using Datadog with EKS.
Amazing.
Yeah, because they complement each other so well. When you think about how EKS makes your life easier to use Kubernetes and AWS, Datadog automatically with our Kubernetes integration allows you to collect all your data, looking at all your resources, your Kubernetes resources, your pods, most importantly, and being able to see everything from the events to all the lifecycle things in the state of each of your resources are going on, and it's surfaced within the app. Also being able to take advantage of, as Lucas was talking about before, the three pillars of observability: metrics, traces, and logs, and Datadog does that and more. So you can do that today with EKS, and we also provide a very performant agent in order to do that. And just to give you an idea of underneath the hood, what that looks like and how it works, how we monitor environments like EKS has evolved over time. And this is a look at our current architecture. I think is pretty cool. We have this idea of the cluster agent, which serves as a proxy for the API server. So it allows to prevent too much load to go on the API server, but it's able to collect data across your cluster. And then we also have the agent running on each of your nodes to be able to talk to Kubelet to get the full picture of what's going on in your EKS cluster and other clusters as well.
And this Datadog cluster agent that acts as a proxy, John, is pretty new, right?
This whole space, Kubernetes, EKS is new. This is all new. But
yes.
This has been generally available for some time. But
and in that way, we can reduce the load of the API server because the Datadog cluster agent will proxy all requests. So the Datadog node agent just stay focused on collecting gathering metrics from Kubelet and sending over to Datadog cluster agent in order to aggregate those metrics. And once they aggregate, it publishes to Datadog, so reduces a lot of load from the API server.
Exactly. That's one of our key focuses in making your life easy with not only your overhead, but making sure that the overhead of your observability is minimal. So we do that. And to get to that point of being able to minimize the load, being able to get the full advantage of Datadog that it has to offer with our observability as well as our security offering, there's a number of ways that you can deploy and manage the agent. Let's see what the poll says and how people are operating today. And at no surprise, most people are using the Helmshark.
Yes, we imagined it. Like we discussed it yesterday, folks, and we expected that most people are using Helmsharks.
Mm-hmm. But I do see the operators growing in popularity at 15%. Some are using manual with the daemon set. And
someone is using EKS Blueprints?
Say it again?
Is someone using EKS Blueprints?
Maybe. We can check the chat. But anyway, just a quick overview of these options. So our recommended methods for deploying and managing the agent are the Helm chart and our operator, which is in public beta. As a heads up, the operator will become generally available very soon. Some of the benefits, though, of first the Helm chart is you have one config file to be able to simply deploy the agent, and for those that are using Helm. And the operator, it's really an evolution of that. Not only is it a simple way to declare and deploy it, like the Helm chart, it limits the risk of any misconfiguration. It's another layer of automation as you declaratively state what you want. It makes Datadog get treated as a first-class resource, and it gets to partake in the reconciliation loop of Kubernetes so that we get visibility of ongoing status, as well as making sure that it is reaching the desired state. And out of the box, it also is embedded with Datadog's own best practices for managing and operating Datadog. So we actually use Datadog in-house on our own infrastructure for serving thousands of customers. So we dog food, and we're sharing our expertise and how we do it ourselves through the operator. So yeah, it's intended to help our customers.
And it's really important to say about the operator, if you permitted, John, like chiming in. So like an operator, for those who don't know, is a way to extend the API server with custom resource definitions. So CRDs stands for custom resource definition. So with that, we are able to create an object of this kind. So Datadog agent is a kind, the kind is Datadog agent, and we are just able to create this kind because of the CRDs that the operator will install for us. So as John said, it will take advantage of all the Kubernetes high availability and reliability ways to guarantee their applications up and running. So with that, for that reason, it limits the risk of misconfiguration, as John said, the reconcile loop and everything. So yeah, it's pretty new. When, John, when you said it's going to go live, the operator?
Very soon.
Very soon. It's in roadmap.
Yeah, we're talking very short term. And yeah, extending the Kubernetes API to include the Datadog agent like this, and as well as being able to enable other aspects of Datadog. The operator makes that so simple. Being able to enable NPM, for example, is just one config line, and being able to also manage things like Datadog monitors and other things will be added to extend this. And the operator pattern with Datadog gives us more flexibility to add more automation, more configurability in this way. So I recommend people checking it out. And yeah, and we'll continue to maintain the Helm chart, and both will be considered recommended.
Awesome.
Mm-hmm.
So since John is going to a live demonstration, right, you're going to cover the metrics, logs, and traces pillars. So I think we can jump in straight to scaling using custom metrics.
Yeah, so one of the valuable pieces of using Datadog in conjunction with EKS and other Kubernetes environments is being able to use Datadog as a metric server, your external metric server, to use metrics like CPU to automatically scale, horizontal pod auto scaling. So being able to scale up and down the number of pods based off of your load. Like we were talking about again, the theme before of operational overhead is real. Human engineering time is real, and the more you can automate, especially with scaling, so that you're making sure that you're making things available and as performant as possible, is critical. And this is a reminder that we offer this, and it's actually recently we also offered the option to do highly available HPA. So being able to add redundancy to the metrics that are being served for your HPA, for Datadog as your external metrics provider. So
that is an example of the Datadog operator installed in the cluster. So again, we are just able to create this kind Datadog metric because we are using the operator and it's extending the API server. So this is the customer service definition of it. So it creates a metric. We want to look at requests per second in our Nginx container, and we are going to create the HPA that stands for horizontal pod autoscaler, pointing to that customer service definition, to that custom metric, and in that way we can scale by customizing metrics that the Datadog agent exports for us. So any sort of metric that your application exposes or the Datadog agent can collect and expose for you is a metric that you can use to scale your applications. Don't stay in the defaults like CPU and memory. Maybe you have to look at, I don't know, some of like a queue, like some items in a queue, or maybe requests per second. So the Datadog agent will help us with custom metrics as the Prometheus adapter does, but with much less effort and a lot of operational overhead. We are saying a lot of operational overhead today, but reducing, and this is real, as John said.
Mm-hmm.
Great. So here we have some Datadog AWS integrations. So as I said before, one of the key metrics to monitor is the resources that we have inside of our account, because an application that runs alone inside EKS is nothing, right? We need some other services, some other integrations, such as load balancers, EBS volumes, depending on the applications. So the Datadog AWS integrations pulls in the CloudWatch metrics and events, so we can visualize everything from a central platform. So here's an example. We are looking to the ELB metrics, so we can see how many health hosts do we have, how many unhealthy hosts we have, requests per second on the load balancer. And again, just look at those in just one single panel. So for that reason, it's really helpful. We can have all our monitoring and observability stack in just one way to look at. And since we talk a lot about ways that we can install our agent inside the cluster, we are going to introduce you EKS Blueprints.
Yeah, I'm excited for this one because
me too.
Customers using EKS, they want a simple way to be able to have infrastructure as code with EKS, and all EKS Blueprints is a framework for simplifying the process of using Terraform or CDK and increasingly other technologies with EKS. So their batteries included modules to be able to take advantage of all the different open source tools that you can use with EKS in a very simple way. So it's addressing a couple pain points that are worth calling out. One is being able to do soft multi-tenancy in an easy way, as well as being able to configure add-ons without having to do all the complexity that normally requires some real expertise. So being able to configure add-ons such as Argo CD or Datadog. And in a moment, I'm going to walk you through just how simple it is to be able to use one either CDK script or Terraform declarative script to say what you want in your infrastructure in one file, and then underneath the hood, AWS, as well as this new ecosystem of add-ons that includes Datadog to be able to plug that in without having the expertise to do any of this.
So as, like, if you permit me, John, but as we've seen many customers with like difficult to install add-ons inside a cluster because each add-on needs to be maintained. So as I said before, one of the pain points of those who are using Kubernetes is the cluster upgrade. EKS deals with that for us, but we have to wait also to upgrade the add-ons and maintain the add-ons at the same version to guarantee that no API version will broke, because sometimes if you upgrade your control plane without upgrading your add-ons, maybe an API server endpoint is being deprecated, and if your add-on uses that API server endpoint, sorry, but it's going to broke. So the EKS Blueprints also helps us to maintain and guarantee the upgrade of the add-ons, and it's really, really, really easy, folks. and John is going to present us, I think, now the way that we can implement the Datadog cluster agent and provision an entire new cluster with just few lines of code with the EKS blueprints.
Indeed. So I'm going to share my screen. So jumping straight to Datadog's docs, I'm going to walk you through how it really is only 3 steps to have an EKS cluster with Datadog as an add-on. So you can start monitoring and take advantage of all the observability and security that Datadog has to offer. So it's really just 3 steps. First, install Datadog add-on.
John, we are not seeing your screen yet. It's loading.
Oh, you're not? Oh. Sharing on. Stop sharing and try it again. Entire screen. All right, we're good?
Yeah, we're good now. Yes. Go ahead.
Cool. So 3 steps. We're looking at the Datadog docs for our new EKS add-on was available at launch with Blueprints. And there's 3 key steps. 1, npm installed Datadog add-on. Second, you need to have the Datadog API key that you get from within the app, and you store it in AWS Secret Manager. And then third, you simply declare that you want the Datadog add-on with your secret, and then CDK deploy. And as an example of what this looks like in real life, along with several other add-ons, this is your TypeScript CDK script for configuring a whole slew of add-ons, including Datadog. So with this, I've been able to configure it with Argo CD, AWS Load Balancer Controller, among others. And I have one that's named West Test 2. And just to show y'all what this looks like within Datadog now that it's set up, it can go to our live containers view. And there we are. There we go. We have West Test 2 configured, and we're already looking at all the pods that are associated with it, including these add-ons. And yeah, with just requiring no expertise, configuring the file with your secret, you now can have end-to-end visibility with your cluster. So here we're looking at several of the things that Datadog has to offer. Right now, we have visibility into your manifest. You can also look at things like, obviously, the 3 pillars of observability, such as our metrics, traces, and logs, as well as things like events. And so that's just how easy it is. And as a reminder, our AWS integration with Datadog, we have over 500 integrations. So we can really work with any environment that you have, including our AWS one, our range of Kubernetes ones, and giving you visibility into just about every aspect of your cluster. So if we look at one of our default dashboards, this is the kind of visibility that you can get as a platform engineer, as an application developer, once you've declared Datadog as an add-on without having to manage the overhead operationally of configuring observability. So in summary, Datadog observability and security solution intended to be comprehensive. And with our new EKS add-on, you now have another way, in addition to all the other deployment patterns and management patterns that we offer, to simply use EKS blueprints in conjunction with Datadog. With a single, literally with one line of code, you can configure and have Datadog automatically deployed and managed for you. And you can start wrapping up.
So I've answered some questions here in chat, but there is one question that I think I need to answer here on mic on live. That is, what are the main differences between installing the Datadog agent using Operator and the Helmshark? So as I said, the operator supports the creation of custom resource definitions. So with the custom resource definitions, you are able to define the Datadog object like you do as deployment, as daemon set inside your EKS. And with the custom resource definitions, we're able to deploy the Datadog agent as you do like any other application running inside EKS. You just execute kubectl apply. With Helm, you need to you deploy the Datadog agent too, but it not will install the custom resource definitions inside in your API server. So that is the main difference, I think. If you want to add something, John, on that.
Oh yeah, those are all true, and both are recommended methods. And just the operator, you get more visibility being a part of the reconciliation loop, and a little bit more flexibility long term as we add more features. And I look forward to hearing what feature requests y'all have for that.
Yes. So just wrapping up a little bit, we're talking about EKS architecture and what are the differences between using a managed service and not using a managed service. We're talking about the different kinds of node groups that we can have. We talk about the observability pillars, so logs, traces, and metrics for those who don't remember. We talk also about observability in the context of the Datadog, and John showed us how we can easily implement the Datadog observability stack inside an EKS cluster with blueprints. And I don't know how many lines of code was that, but it was like 50 lines of code just to provision a complete like cluster with batteries included, add-ons, and the Datadog agent. That is really, really nice. So yeah, and the last one, but not the less important, is EKS Blueprints with the Datadog. And I think with that, we are approaching the end of our presentation, folks. Yeah, I want to know if there are any other questions on the Q&A section. Yes, we have one here. So the question is, do you know when Fargate will support image caching? I can't exactly say that, but we have our containers roadmap publicly accessible on GitHub, and it is in the handouts links of this application. So you can go over to handouts and check the containers roadmap, and there you are able to see which features AWS team is implementing inside our container services and so on. So yeah, John.
Will Datadog's blueprints add-on be available for Terraform? Yeah, more to come on that.
Great, guys. So yeah, do we have any other questions? We still got like 10 more minutes here. Cody, do you still hear?
I am here. So I'm seeing a couple of questions in that Q&A tab. So if you scroll down a little bit, you'll see there's a couple two-part questions. I kind of just want to let you guys run through those and see if there were any that pertained.
Mm-hmm.
Awesome.
Here's one that could be helpful to talk about. If effort or expertise is not an issue, is there still an advantage to using the Datadog? Even more so with various automation tools nowadays. There's one of the key ones is management overhead, as we talked about, of having to maintain infrastructure for your tools. And Datadog is unique in providing a performance solution for managing your infrastructure, as well as the end-to-end observability and having one app, one window
to look at.
To be able to be an app dev and look at APM, and then in the same window being able to drill into your logs and your infrastructure level details, and ultimately saving engineering time. And thousands of customers today have found that Datadog helps them save money at the end of the day. And operate more efficiently, happier engineering teams.
Awesome. There's also next question that is really interesting here. So how do you get management node logs in EKS and how do you integrate the node logs with the Datadog. So for the Datadog aspect, once you have the Datadog agent installed inside your cluster, the Datadog will start to tail the log files inside Kubernetes and send it over to the Datadog panel, and you are able to look at. If you're using an open source solution, a way to gather those logs is to install the FluentB or FluentD inside your cluster, and those can look and tail the log files of your containers that are running inside EKS, and with that you can forward to a log centralizer such as OpenSearch, Elasticsearch, or even CloudWatch. So we get the logs in the same way that we do in the all Kubernetes distribution, because when an application is running inside the Kubernetes, the logs will be written in a folder inside the etc directory, and the Datadog agent and also the FluentB or FluentD will look to that folder and to the files that are there, tail those files, and send to a log centralizer. So that is a way that you can get the logs of the applications that runs inside all the worker nodes that you have. And I know that is not a question, but for Fargate, we support Firelands. So Fargate can send directly to Elasticsearch, OpenSearch, or even to CloudWatch. So we just need to create a namespace and a config map inside a specific namespace, and the Fargate containers are able to send those logs to any log centralizer, such as Datadog also.
Yep, that is definitely true.
John, there's a really good question here. So if you deploy the Datadog agent as an add-on via Blueprints, can you use it for HPA as external metric source?
Yes, you'll be able to use it. It's just like you're using Datadog, but the other management styles with the operator. The way HPA works is it takes advantage of the cluster agent that we were talking about earlier to expose the metrics that you need, whether it's CPU or something other metric that you want to use.
Great. So I think with that we answered the most part of like the awesome questions that you folks asked to us. So Cody, do we want to wrap up and jump in to tell them the actions?
Sure. I would just like to start off by reminding our audience that this session was recorded. So following this webinar, you'll receive an email with a link to access this recording on demand, or you can find this webinar living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So at the top of the hour, I said we had 4 $25 Amazon gift cards to give out, so we're going to follow through on that promise. Our first winner is Morlu H. Our second winner is Abby D. Our third winner is Katarina O. And our fourth and final winner is Lauren N. So to the 4 of you, congratulations. Please keep an eye on your inbox to claim that gift card. But if you don't happen to receive that email in your inbox, just check your spam folder. So John and Lucas, thank you so much for joining us today and for sharing your expertise and walking us through EKS Blueprints. Any final words before we officially close out?
Thank you, Cody.
Yes. No, go ahead, John.
Yeah, thank you, Cody. And it's been a fun talking with you all and engaging with you all in the chat and the QA here, and encourage you to check out EKS Blueprints. We have a blog post dedicated to this, and one line to get it configured with Datadog. And I also encourage you to check out our public Slack for Datadog, and I'll be on there and happy to continue talking with you all.
Great. So thank you, Cody, and thank you all for your presence here. So it's been like really fun preparing this webinar to present to you folks. And don't forget to look at the containers roadmap inside our official GitHub repository. You can check that on the Handouts section here. And yeah, just say thank you. And if you have any kind of request about a service inside AWS, please contact your account team, and maybe we can help you with the requests, because we're going to work in backwards from you. So thank you.
Awesome. Thank you again, Lucas and John. And huge, huge shout out to both Datadog and AWS for sponsoring today's webinar. And to our audience, we really appreciate you spending time with us today. We ask for just one extra moment of your time to fill out a brief post-webinar survey that will pop up here as soon as we close out. But otherwise, we hope to see you all at an upcoming Techstrong Learning workshop or webinar. Everyone, have a great rest of your day.